Hello, good evening, students. Today we are going to discuss the chapter Heron's formula. In this chapter, we can use Heron's formula to find out the area of the triangle when we know the length of all its sides. First of all, we have to check our previous knowledge. We know that area of a triangle. First, here we can considering area of a triangle. We know that area of a triangle equal to half into base into height. We know that different types of triangles. What are the right angled triangle, equilateral triangle, isosceles triangle, and scalene triangles. We know that area of the right angled triangle is half into base into height. Let us consider the right angled triangle. Right angled triangle has one angle is 90 degree. That is considering a right angled triangle ABC. Here we can find out the length. That is considering the length BC 5 centimeter and AB 10 centimeter. Therefore, area of right angled triangle ABC equal to half into base equal to here base is BC, BC into height is AB. That implies half into 5 into 10. That is equal to 5 2s are 10. Therefore, cancelled 5 times. Therefore, here 25 centimeter square is the area of this right angled triangle. We know that only the area of the right angled triangle. By using the area of this right angled triangle, we can find out the area of equilateral triangle and isosceles triangle. Next, we can consider equilateral triangle. What is equilateral triangle? Here in this triangle, all sides are equal. That means here we can considering all sides are equal. Let us consider the triangle ABC. Here all sides are 12 centimeter. Considering 12 centimeter each. Then how can we find out the area of this equilateral triangle? First, we can draw a perpendicular from the base. That means we can draw a perpendicular from the midpoint of the base. That is considering a perpendicular from the midpoint of the base. The midpoint can be denoted by D. Next, here we can get two right angled triangle, triangle ADC and triangle ADB. Then find out the area of this equilateral triangle ABC. First, we can find out the area of right angled triangle, area of right angled triangle ADC. Here, D is the midpoint of BC. Therefore, the length of DC is 6 centimeter. That is half of BC. Here, DC equal to 6 centimeter. Then, by the Pythagorean theorem, we know that h square equal to b square plus altitude square, that is base square plus altitude square. Here, by the Pythagorean theorem, consider the rectangle to triangle ADC. AC is the hypotenuse, DC is the base, and AD is the altitude. Then AD can be denoted by H. Therefore, substituting Pythagorean theorem here, 12 square is equal to 6 square plus H square. That implies H square is equal to 12 square minus 6 square, that's equal to 144 minus 36, that is h square is equal to 108, that is 144 minus 36, 108. That implies h is equal to root 108. Next, we can factorize 108. How can factorize 108 divided by 2? 54, then again divided by 2, 27, then again divided by 3, 9, then again divided by 3, 3 3s are 9, then 3, 1. Therefore, root 108 can be written as, therefore, h is equal to root of 2 into 2 into 3 into 3 into 3. Now we know that squares are multiplying a number by 2 times, and square root as we can take each number from the pair. Now here 2 into 2, we can take one number outside, square root of the number, that means 2. We can take 2 outside, 2 into, then again 3 into 3, twice times will be multiplying. Then each pair we can take one from outside, that is 3 into 3, we can take 3 outside. Next, the remaining terms inside the root is root 3. That implies 6 root 3. Therefore, next we can find out the area of the right angled triangle ADC. What about the area? Area of right angled triangle ADC equal to half into base into height. Now here base is 6 centimeter, half into 6 into the height is 6 root 3. Therefore, 3 2s are 6. Then 3 into 6, 18. Our value is 18 root 3 is the area of the right angled triangle ADC. Same manner, we can find out the area of right angled triangle ADB. This area is also equal to 18 root 3 centimeter square because same length and height. Therefore, area of an equilateral triangle ABC equal to area of right angled triangle ADC plus area of right angled triangle ADB. That implies area of right angled triangle ADC equal to 18 root 3 plus area of right angled triangle ADB, that is also 18 root 3. Therefore, the total area, the area of an equilateral triangle is equal to 36 root 3 centimeter square. That means here we can find out the area of an equilateral triangle by using area of the two right angled triangle, and finally we will add the area of these two triangles. Next we can considering isosceles triangle. Isosceles triangle. In the case of an isosceles triangle, we know that opposite sides are equal. Just considering an isosceles triangle ABC. Here AB and AC are equal. Let us consider AC 12 centimeter and AB 12 centimeter and BC 8 centimeter. How can we find out the area of this isosceles triangle? First, we can draw a perpendicular from the base. That means here we can find out the perpendicular from the base B meeting at the point D. That is, draw a perpendicular from the midpoint of base BC. Here, total length of BC is 8 centimeter. Therefore, DC is 4 centimeter because we can draw a perpendicular from the midpoint of BC. Therefore, DC is equal to 4 centimeter. Now, here the triangle ADC is a right angled triangle. Therefore, the opposite side AC is a hypotenuse and the perpendicular length is called altitude. Altitude can be denoted by the letter H. Therefore, find out the area of right angled triangle ADC. But here we have to find out the length of the altitude. By the Pythagorean theorem, we know that in the case of a right angled triangle, hypotenuse square is equal to base square plus altitude square. Now here hypotenuse is 12, therefore 12 square is equal to base DC is 4 square plus altitude can be taken as h, therefore h square. Therefore h square is equal to 12 square minus 4 square, that's equal to 144 minus 16, that is equal to 128. H square is equal to 128, therefore h is equal to root of 128. Then next we can factorize 128. 128 factorize into 2, 64. how many times? Then 2, 32 times. Then again 2, 16 times. Then again 2, 8 2s are 16. Then again 2, 4 2s are 8. Then again 2, 2 2s are 4. Then again 2, 1 2s are 2. Therefore, the fact is 2 into 2 into 2 into 2 into 2 into 2 into 2. Therefore, h is equal to root of 2 into 2 into 2 into, how many 2s are there? 1, 2, 3, 4, 5, 6, 7. 2 into 2 into 2 into 2. Now here, considering the square, we can multiply a number by twice, and here we can find out the square root. Therefore, we can take a number from each pair. We can take one number from each pair, that is considering first 2 into 2. Here we can take 2 outside. Then again 2 into 2, we can take 2 outside. Then again 2 into 2, we can take 2 outside. Then remaining square root, inside the square root, we can consider square root of 2. Therefore, h is equal to 8 root 2. Therefore, area of the right angle triangle ADC, area of the right angle triangle ADC, triangle ADC equal to half into base value is 4, 4 into 8 root 2. Then 2 2s are 4. Therefore, our answer is 2 into 8, 16 root 2. Therefore, area is 16 root 2 centimeter square. Then again, we can find out the area of the other right angled triangle ADB. Same manner, here we can find out this area is 16 root 2 centimeter square. Therefore, area of this isosceles triangle is adding the area of these two right angled triangle. Therefore, area of isosceles triangle ABC equal to area of right angled triangle ADC plus area of right angled triangle ADB. That's equal to 16 root 2 plus 16 root 2. That's equal to 32 root 2 centimeter square. Next, we can considering scalene triangle. In this case, we can considering a triangle with three different sides. That is, the sides are different length. That is considered in this triangle. We can find out the area by using Heron's formula. Here we can use Heron's formula. Heron's formula can be used for finding area of the triangle when we know the length of its all sides. Then the sides are different also. The length of the sides are different. Let us consider the triangle with different length. Consider the triangle ABC. Here AB is 40 centimeter, BC is 42 centimeter, and AC is 30 centimeter, like that. In this triangle, how can we find out the area? Here, in this case, here we cannot draw a perpendicular from the midpoint. That is why we can use Heron's formula. Therefore, in this formula, first we can find out the perimeter of the triangle ABC. What is perimeter? Perimeter means adding the length of the three sides. That is, here perimeter, let us consider BC. The side BC is A and side AB is B and side AC is C. Therefore, the perimeter of the triangle is what? We have to adding the all length. That means perimeter means it is the boundary of the triangle. Therefore, how can we find out? It is equal to A plus B plus C. That is equal to 42 plus 40 plus 30. That is equal to 112. Perimeter is in length of the triangle. That is, it is called 112 centimeter. It is expressed in a unit centimeter. And next we can find out the semi perimeter. Therefore, half of the perimeter we can calculate by the Heron's formula. It can be defined by the using semi-perimeter. Therefore, semi-perimeter is equal to half of the perimeter. Therefore, half of a plus b plus c. That is half of a plus b plus c. What is the value of a plus b plus c? That is 112. Therefore, 112 divided by 2 is equal to, what is the value? It is equal to 56 centimeter. Therefore, semi-perimeter can be denoted by S. Therefore, by the Heron's formula, we can define area of triangle ABC equal to square root of S into S minus A into S minus B into S minus C. Here, S minus A equal to S minus A equal to 56 minus A what 42, that is equal to 14 centimeter, and S minus B equal to 56 minus B what 40, therefore that is equal to 16 centimeter. Then S minus C equal to 56 minus 30, that's equal to 26 centimeter. Therefore, next we can find out the square root of this value. Therefore, area of triangle ABC equal to square root of S equal to 56. 56 into 14 into 16 into 26. Then again we can factorize into each terms, we can factorize. Therefore, 56. 56 can be factorized into then again 2 times 7, then again 7, 1. Now here 56 divided by 2, 28, 28 divided by 2, 14, then 14 divided by 2, 7, 7 divided by 7, 1. Therefore, 56 can be factorized into 2 into 2 into 2 into 7. Then 14 can be factorized into 2 into 7. Then 16 can be factorized into 2 into 2 into 2. Then 26 can be factorized into 26. 26 can be factorized into 2 into 13. That implies next we can considering 2 into 2 square root. Square root we can take it as one number outside. That is each pair we can take one number outside. The first 2 into, then next 7 into 7 we can take 7 outside. Then next 2 into 2, then we can take 2 outside. Then again 2 into 2 we can take 2 outside. Then again 2 into 2 we can take 2 outside. Then remaining 2 into 13 inside the square root. That's equal to 2 into 2, 4, 4 into 2, 8, 8 into 2, 16, 16 into 7, 112, 112 into root 26, 112 into root 26 centimeter square.